Assuming ideal solution behavior, what is the freezing point in degrees Celsius of a solution of p-xylene C6H4CH32 in a 0.25 kilograms of benzene if the solution boils at 84.8 degrees Celsius? First, let's summarize the information given to us and what we need to find. We know we need to find the freezing point of the solution, or TF of solution, and we're given that this solution is made out of an unknown amount of p-xylene dissolved in 0.25 kilograms of benzene. We're also given a lot of information about our solvent benzene here. We know that the boiling point of benzene, or TB, is 80.09 degrees Celsius. We know that the boiling point elevation constant of benzene, Kb, is 2.64 degrees Celsius per mole. Next, we know the freezing point of benzene, Tf, is 5.49 degrees Celsius. Lastly, we're given that the freezing point depression constant of benzene, Kf, is 5.07 degrees Celsius per mole. Lastly, we're given that the boiling point of the solution, TB solution, is 84.8 degrees Celsius. So let's go back to our focus of finding the freezing point of the solution. We know that the formula to find TF solution is freezing point of the pure solvent minus the freezing point depression, which is delta TF. So the freezing point of the pure solvent, in this case benzene, is 5.49 degrees Celsius. That's given in the prompt. Next, we know the formula for delta TF is I times Kf times M. I here is the Van Hoff factor, and for p-xylene, Van Hoff factor I equals 1. Next, the Kf is the freezing point depression constant, and for benzene, that is Kf equals 5.07 degrees Celsius per mole. Lastly, we need molality, and in this case, molality is unknown. So, to find the freezing point of solution, really the first thing we need to find is calculating the molality. So, we'll calculate molality of the solution from the boiling point of the solution given to us. So we know the formula to calculate a boiling point of solution is taking boiling point of pure solvent plus delta TB, which is the boiling point elevation. We're given that the boiling point of this solution is 84.8 degrees Celsius. We also know that the boiling point of the pure benzene given to us is 80.09 degrees Celsius. From that, we can calculate delta TB equals TB solution minus TB solvent. That's going to be 84.8 minus 80.09, giving us 4.71 degrees Celsius. Now that we know delta TB, let's look into the formula of delta TB. Delta TB is calculated from taking I times Kb times molality. So, if we rearrange this formula, we'll have molality equals delta TB divided by I times Kb. So if we substitute numbers in, that's going to be 4.71 divided by 1 times 2.64, and we'll get an answer of 1.784 moles per kilograms. Now that we have the molality of the solution being 1.784 moles per kilograms, let's go back and calculate the freezing point of the solution. The formula for freezing point of solution, as we discussed earlier, is TF solvent minus delta TF. And we know the formula for delta TF is I times Kf times molality. So now let's substituting numbers in. We'll have 5.49 minus 1 times 5.07 times 1.784 moles per kilograms. That's the molality we calculated earlier. And if we do the math, the answer is going to be negative 3.55 degrees Celsius. So that is going to be the freezing point of the solution, and that's the answer to this problem. Thank you for watching.